All right, one more polar coordinates problem before we start into complex numbers. So we have 3 plus 3 sine theta that we are going to be graphing, which is a lovely little polar graph. And you'll remember from your work, all of that work with polar graphs and polar equations, that this is going to be a cardioid. And it's a cardioid because our number in front here, the 3 are 2 numbers in front. The 3 and the 3 are the same. So that's going to make this a cardioid. So it's going to be that guy that kind of looks like a heart-ish, flat bottom. Since it's a sine equation, it's going to be symmetric about the y-axis. So if that can get you through if that can get you done with the problem, symmetric about the y-axis, the cardioid, if that can get you to the right answer on a multiple choice test and you pick out those things, go with it and be done. Other thing that if you put this in your calculator, what you find is that your two little, what would be x-intercepts here, are at 3 and negative. And our maximum r value is 6, because 3 plus 3 is 6. So that's the other thing that we really worked with, was that maximum r value. So those 3 things, cardioid, maximum r value, and y-axis symmetry, may get you through the problem without even having to put it in your calculator. If you're confident with those things, don't be scared, just pick the answer. If you need to put it in your calculator to see this shape, which I just do very poorly, then you can absolutely do that as well. All right, last polar coordinates problem. We're finding d cubed. So we are going to use that theorem, de Moivre, where that 3 is going to become a power on our r, and we're going to multiply it by our theta. So d cubed is going to look like this. 4 cubed times cosine of 3 over 1 times 5 pi over 12 plus I sine of that same angle, 3 over 1 times 5 pi over 12. And now from here, we just need to simplify. All your answers here are going to be in standard form. Remember, standard form is a plus bi. So 4 cubed is 64. And here my 3 and my 12 cancel to make a 4 in the denominator. So I'm doing cosine, not of 12ths anymore, 5 pi over 4. And sine of 5 pi over 4. And from here, we're just going to put in our values, the unit circle values, and simplify. So cosine of 5 pi over 4, 5 pi over 4 is third quadrant. So we're going to have both sine and cosine are going to be negative. And all my fourths are radical 2 over 2 for sine. Last step is to distribute that 64 in, and you're effectively dividing by 2. So this is going to be negative 32 square root of 2 minus 32i square root of 2. And that's your final answer. Polar coordinates, done and done. Vectors are next.